Okay, Math 2 folks, here is the second part of the review. When we just got done, we were doing a problem with similar triangles where we have one triangle inside another. Same thing here. We're going to have a small triangle that is similar to a larger triangle. So the small triangle, we have some unknown, SO. Well, here, I'm going to actually say we're trying to find this, but let's see if we can find this one first. And this one we know is 4. Now, in each case, we have angle L that is the same, and since these are parallel, we know that these corresponding angles are the same. So, because of angle-angle similarity, we know that these are similar triangles, therefore their sides are proportional. So, the small one over the large one is the same as this small one over the large one. What is the large one? Well, it's not 12, that's just this part of it. It's the whole thing, 16. So from here, if we multiply both sides by 28, we get x equals 7. So x equals 7, that means that this is 7. The whole thing is 21, so 28 minus 7 equals 21. All right, number 11, determine which of the following transformations are dilations. This is just asking if you can make sense of coordinate notation and remembering that a dilation means everything is scaled proportionally, evenly. So that means our x and our y values would have to be multiplied by the same thing. So that's a dilation. This is a dilation because they're both multiplied by 2/5. But here they're multiplied something different. So the horizontal dimension is multiplied by 5, the vertical by 3. So those wouldn't count. The transformation shown is a dilation with a scale factor of, well, I'm going to find this by saying, look, here's 1, 2, 3, and here's 1, 2, 3, 4, 5, 6. So this is a scale factor of 2. That's the first one. And then in words, the second one is what? Well, a dilation with a scale factor of 2 means that I would dilate this to here, this to here, and this to there. So that's what happens when I dilate it to 2. And from there, if you look at it like this, you can see, in fact, that it's a mirror image. So this is a reflection over the x-axis, and that means that instead of this being 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, instead of this being 6, 6, it's 6, negative 6. So it must mean that our x stays the same, but our y becomes negative. Extra credit here, I will just give you this hint that if we know that I've got 3 triangles, so I've got A, B, C, and if I draw the middle triangle here, like this is angle ADB, right? So if I take this one and I flip it around, and then I've got this one here. I'm not doing very good with right angles, but then this is triangle DCB, right? Then I know that angle A is similar, so I'm going to have angle-angle similarity. These two must be similar. And I also know that angle C is similar. So these two are similar by angle-angle. These two are similar by angle-angle. Therefore, they are all similar triangles. So that must mean that I got this mixed up. That this and this and this are all, they're all similar triangles. So knowing that, this one's 12, right? This one's 2. This one's 10. What can we find out about X, Y, and Z? The other thing you're going to need to know about this is the Pythagorean theorem. So that's where we say in any right triangle, if I have two sides, the square root of one plus the square of the other equals the square of the third. And that's where we're actually going to go over in class next. But that's why it's extra credit. A little extra bonus, you're going to need that and this information to solve this. But I'm going to leave you to work it out. Okay, good luck, and we will see you in class.